Good morning, participants. The session will be starting in a few minutes. Please hold back.
Rajesh sir, good morning.
Very good morning, Doctor. Good morning.
Thank you, sir. Welcome to our.
Ma'am, you can call me if anything went wrong. I have a different net connection which I'm using, and you can.
Okay. Good morning, participants. I request everyone to please unmute your devices. Uh, Good morning, everyone. Welcome to the last day of webinar series. So today our session will be taken by Mr. Rajesh Sharma, Head Technical Department, Suzlon Energy Private Limited, Pune. Sir has completed his Bachelor of Engineering from Amravati University and has a 23 years experience in academic learning and development organization. Also, he's experienced in work field like thermal and renewable energy, steel and manufacturing industry. Sir has successfully developed, implemented competency framework and technical training, successfully handled recruitment of 760 plus GETs and DETs from many engineering colleges. I welcome sir for this today's session, and I hope that it will be beneficial for everyone. Sir is going to speak on state of art technology of wind turbines and its scope in engineering. Over to you, sir.
Thank you very much. Thank you. Good morning, participants. I'm Rajesh Sharma, as already been introduced. I will be going to discuss with you regarding the wind turbine technology, which is the new trend into a renewable energy. So it is all about what I come to know from Pandre sir and the team, that there are the students who are sitting from all the backgrounds. Basically, there are more of the electronics people who are sitting there, electronics, CNTC, and a few are from mechanical background also. So let us start with this technology. What is this and how it will be beneficial for you in future for getting the opportunity to work with the industry. So to start with, let me take you. So the first slide which is in front of you, if you are able to see that, I hope you are able to see my mouse click also there, that this is a simple block diagram which will help us to understand how the kinetic energy, what we can talk, or the wind energy, which is converted into the electrical energy. So when we talk about kinetic energy is converted to the electrical energy, first of all, this kinetic energy is extracted from the wind, and when we extract it from there is an aero turbine. So aerodynamics engineers are required here in aero turbine. Then this aero turbine will it's also called as the rotor, and when this rotor will rotate, it will rotate the gearing system. So there may be a gearbox kind of the technology which is there. The gearbox, it is basically step up type of the gearbox where you can gear up, you can increase the RPM, and those RPM will be ultimately has to couple to the electrical generator. So while coupling to the electrical generator, basically some kind of the couplings are required to be used there in all kind of the technologies. So there is a coupling mechanism which is there. Post this coupling mechanism, there is electrical generator. So electrical generators are also of different type. There are two types basically. One is synchronous and another is asynchronous generator. Post this, output power. The output power is the electrical power, which is. So when you look at this block diagram, you come to know that this kinetic energy of the wind through the aero turbine, aero rotor, will be given to a gear mechanism, will be coupled to the generator, and the generator will be giving the output power to and the generator will be giving the output electrical power to the grid. Now when we look at all the locations, we are able to see that there are the feedbacks or the inputs are coming. So this is the heart and soul of any wind turbine. So it's come to the controller. So the output is taken from here as a feedback, the output is taken from the coupling, it is given as a feedback, then output from the gearbox is taken. So this is basically a heart and soul called as the controller of the turbine, and it is even monitoring the input, taking the inputs, even it is monitoring the output, and ultimately the total control is there. So when we are having electronics engineer, control parts are there. So mostly the electronics, ENTC and control engineers have been used here in this technology. Have a lot of scope over there. Let me go to the next slide. I'm facing some toggling problem. Slides are not getting toggled.
Sir, just click on the screen. Just click on the screen where it is playing, and then you will be able to toggle.
Yeah, correct. Thank you. So now this is the block diagram which I have explained you. I have given you a brief introduction about what is that. And then now we will be going to the next slide. So what we are talking about, whatever the block diagram which I have shown, if you can see to this is the machine, or it's called as the turbine, or it's called a wind turbine. You can see. So across the world, the wind turbines has been classified basically in two types. Mostly they are horizontal axis, if you can see. So one is upwind turbine and second is the downwind turbine technologies. Mostly the upwind turbine technologies are basically when the wind is coming from the front end and touching to the turbine and rotating it. Turbine, when we talk, it's a generator which rotate, right? And downwind, some technology when the wind comes from the rear end of the turbine and rotate the turbine, then those kind of the technologies are called as the downwind turbine. Now, when we talk upwind and downwind, basically most preferable technology across the globe is upwind technology, three-blade upwind technology. And when we talk about upwind technology, mostly all, you can see a picture on the left-hand side. Basically, it's a horizontal to the ground. When we look at this top, it is exactly horizontal to this ground. That's why it's called as the horizontal technology. The question may come to the mind whether there are vertical axis turbines available in the market. Yes, but basically vertical axis turbines are not used for commercial purpose. So all the commercial purpose technologies are either upwind or downwind, but it is basically a horizontal technology, right? Means the mechanism is exactly horizontal to the ground. Any turbine, any manufacturer across the world, if you can take, they are having divided the complete turbine in one is called the bottom section. So there is something which is at the bottom of the turbine. Then there is something, when I am talking something, there is a control system which is at the top of the turbine. It's called as the rotor. One which is rotating is called as the rotor. And on the rear end of the rotor, you are able to see something, a kind of a box where it's written Suzlon 2000. It's called as the nacelle. So something is at the bottom here, something at the top, it's called as the nacelle. Something which is rotating is called as the rotor. And everything, the assembly of this is done by some kind of the mechanism called as the tower on which it is standing. Like we can talk about the electrical tower or mobile towers or the different towers. So it is basically a tower on which this complete assembly is assembled. Now, if we look at the cross section or the conventional process, you can see that if we open a cross section view of the wind turbine, we are able to see that this wind turbine has the first part is called as the blade. Second part is called to which the blade is connected is called as the hub. And the third is tower shell. So this is the tower shell, and this is completely is called as this completely is called as the nacelle. This nacelle cover, the unit of the glass fiber which is covering the complete assembly is called as the nacelle cover. Then we are having the main bearing. You can see the main bearing, like here is a main bearing, and there is a gear mechanism. So there are some companies who are having two number of main bearings, or there are some companies having single main bearing. Then there next to that you are able to see on the 6th point, that is the gearbox. So there are some companies who is having the gearbox, and some companies may not be having a gearbox. So it's a with gear or without gearbox technologies are there. And next to gearbox you can see there is the generator. So ultimately the generator, where the kinetic energy which is coming from here will be converted to the mechanical. From mechanical it is generated here, and the electrical power will be absolutely we are getting from here exactly, which goes down to the bottom. So this is the second slide, and then we can go. So now we can understand, yes, I'll go back. Now we understand that yes, the kinetic energy of the wind is coming, rotating the rotor, which is made up of aero turbine or aerodynamic blade. Then there is a mechanical system called the gear, which is coupled with again a mechanical system, and which is connected to the electrical generator. Maybe we might have heard those are from electrical background or electrical subject they have. There is a synchronous and asynchronous generator, two generators there. And the control of this complete process from kinetic energy to this is controlled by our electronic guys, right? This is how the things happen, and this everything is happening in this a big machine which you are able to see. Next to that, then we open the cross-section view, and then in this cross-section view we understand, yeah, the process will start from here and it will be going to this part. Ultimately there are panels also you are able to see, which are called as the nacelle control panel or the top control panel. Then we can go. So what is this blade? Basically these are the blades which are 14 meter to 62 meters. 62 meter long blades are there. If we can count 60 or 60 meter, it is 180 feet. So when we talk about 180 feet tall blade, means it's 18 storied building. If you can take 10 feet of storied building, so an 18 feet storied long tall 18 storied building is there. So one blade is so long or so tall we can call, and the weight of one blade is approximately 1200 kg to 12,000 kgs. Depend upon the machine, depend upon the size of the machine, depend upon the megawatt of the machine, the blade weight, you can understand that 12,000 kg is only one blade, and each turbine required 3 blade. So there is 36,000 kg is the only weight of, or we can talk 36 ton, or we can talk 36 ton is the weight of the blade. Can I get any input? Am I audible?
Yes, sir.
Am I audible?
Yes, sir. Clear.
Absolutely clear?
Yeah,
Yes.
clear.
Any feedback? Anything wrong?
No, sir, nothing, sir.
Thank you. So, but you know, this is a massive technology. You can see 12,000 kg, 3 blades, 36,000 kg, 3 blades we can talk together, and they are made up of the glass fiber, which is the lightest material available in the world. Even there is a carbon fiber associated with, which is the, sorry, is it okay? Have a aerofoil shape, and you can take that this technology right now we are designing in India. Suzlon is the only company who are having everything which we can do in-house, and we are the indigenous company. So there are many companies who are working, but when we talk about Suzlon is the world 3rd largest, and you know, Asia's first company who is manufacturing this. So the only function of this blade, you know, is to convert the kinetic energy to the mechanical energy. Now when the blades are there, so the blades are connected to a component called as the hub. on the slide, you are able to see a hub. So you can see there is one blade which is connected to this side, one blade on this side, and one blade on the rear end of this. You can see there. Okay. So the part which is used for connecting only blade is called as the rotor. The hub is called as the hub. So you can see the hub is there, to which only we attach the blades. Okay. Even the weight of the hub, when we can talk, it varies from 3 ton to 12 ton, depend upon the strength and depend upon the rating of the machine. We can see that, right? Then we can go. So then we can go for the machine, and we can see that these machines are installed on this type of the tower. You might have seen this type of the tower. You might have seen in the electrical power evacuation. So these towers are called as the lattice tower. So these are the old era tower. I can talk in terms of in 90s we are using this, or 80s or 90s we were using this type of the tower, and in 2000 we are using this type of the tower. So there is a lattice tower and there are the tubular tower. So, and this machine, if I can talk about this, it is 100-ton machine which is placed at the height of 80 meter, 90 meter, 120 meter, and it is 140 meter on the earth. So you can think 140 multiplied by, so it is 45 storied building, approximately 45 to 50 storied building. At the top of 50 storied building, the machine is placed, and the OMS engineer will climb all the way from here or go by the elevator and perform the work here. So this is a massive technology which I want. It's a gigantic machine which I would like to share with you. And this is completely made up of the steel structure. This is made up of the steel and the steel plates. That is what you are able to see. Now, recently this has been designed, which was not earlier. Before 2014, it was not there. Now companies are going for, this is called as the hybrid technology. Half is the lattice and half is the tubular tower, you know. And on the top of this tubular tower, you can see this 100-ton machine, 100+ ton machine is there. And this is the tower, which is approximately 107 ton. So 107,000 kg is the weight of the tower. 100+ ton is the weight of the machine, and which is put at 120 to 140 meter. You can think through, it's a massive one, where only to manufacture this, to bolt this, to tight this, we require 9,000 bolts. So like that, there are you can understand and you can imagine that what a huge scope is there for a mechanical engineer, what a huge scope for there is an aerodynamic engineer, what a huge scope for electronics and telecommunication engineer, what a huge scope there for the control system people, power electronics, electrical, you know. And you can see, you can understand the more thing. Even you can see the beauty of this, that this place where the tubular and the lattice is connected, here there is a transition piece. It means this tubular tower and this transition piece has to hold this 200+ ton of the weight. And that is the beauty of design, that this is a transition piece which will hold the complete tubular tower and the machine at the top. And you can see that here are the panels, and from here the engineer will go up and done the maintenance of the machine. And here you can see a circular hole through which the elevator come from bottom to the nacelle to the top. The elevator will come from here, it will go to this. This is a transition piece where we are having control system. From this transition piece, it will go to the top to the nacelle and perform the work and come back. So that is what is the major role which has been done by most of the engineers. Now, this is about the tower. We can see this is the actual machine. You can see, you might see across when you go to Gujarat side, you can go to Rajasthan side, or when you can go to Andhra Pradesh or Tamil Nadu. In most of the places, you will find that you will find that there are multiple machines, this kind of the machines, right? So the main part, this is a rotating part. If I can go back slightly, I can go. This is a rotating part, and in the rotating part and the stationary part, which is on the top of the nacelle, will be coupled, will be joined by the main shaft. It is called as the rotor shaft. Means this is a rotor shaft which will come on this side. It will connect a rotor. On this side, it will connect a gearbox. So the shaft between gearbox and this will be called as a main rotor shaft, we can call, which connect the rotating part and the stationary part of the gearbox. Okay. Weight of this main shaft varies from 2,390 kgs to 8,529 kgs. So you can see approximately 1 ton is the weight of this rotor shaft too. And this is the bearing which has to handle the complete load of 35 to 40 ton. And this is the huge bearing which has been used over there. So the bearing, you can see that it's a tapered roller Meyer bearing, double spherical tapered, is a huge bearing. If you can talk about the bearing, 282 small machine, then up to 1000 kg, approximately 903 kg is the weight of the bearing. Simply in this bearing, you required at least 24 kg of the grease to be filled. From that, you can understand how massive machine is there. That is the whole idea to explain. And the main function of this bearing to handle all the radial and axial forces which are coming from the wind and from the gear mechanism. Then this is basically that rotor shaft is connected to the gearbox. I just want to tell that whenever we are manufacturing any wind turbine, the wind turbine are basically uses the generator. The generator are basically synchronous or asynchronous. Most of the companies are using asynchronous. When we talk about asynchronous, when we are talking about the asynchronous, we are talking that it has to move beyond synchronous speed. So if we can talk about synchronous speed, any speed which is beyond the synchronous, when we talk, we have heard in engineering, we have learned in engineering that synchronous speed is ns 120 f by p. So when we talk ns 120 f by p and any synchronous speed, 120 f by p, p is the frequency, f is the frequency and p is the pole. So if we can simply take the example of 2-pole machine or 4-pole machine, if we take example of 4-pole machine, then 4, if we can take p is equals to 4, f is equals to 50, we know synchronous speed is 1500. Means the generator has to rotate at 1500 rpm, then and then only the electrical energy is possibly generated. So when I'm talking 1500, we can't rotate a rotor at 1500 rpm. Otherwise, you know, the one blade will be in Mumbai and one blade will maybe fall into Pune and one blade may go to Jaisalmer, Rajasthan or somewhere else. So that is impossible and it's not possible, you know. So what I mean, there is a gear mechanism. The function of the gearbox is basically to increase the rotor RPM from 10 to 15 RPM to 10 to 15 RPM to 1500 RPM. So that is the whole objective of this gear. I hope you understand that to rotate a rotor at a higher RPM, we require the gearbox which can shift the rotation from 15 to 15 rpm to 1500 rpm to 1200 rpm and so on and so forth. And even the gearbox weight varies from 7.4 ton to it goes to 18 ton. And huge accessories are associated. There is a oil field, there is a cooling system, there is a temperature sensor, there is a pressure sensor. So lot of electronics and sensors kind of the things are associated with the gearbox. Okay. Then we can see wind is unpredictable. It always keeps on changing. There is no constant. And when we want to generate the electrical energy, we want a constant speed, you know. So the constant speed will be maintained by aerodynamic thing. Most of the time, even we are having the scope for the automobile engineers or the diploma from automobiles, because we are having the hydraulic systems are there. So in the turbine, in most of the wind turbine, they are using hydraulically operated brake, hydraulic operated mechanism of the blade, and even applying the brakes to the dish, even pitching out the blades and all that. So there is a hydraulic systems are also even applying to the brake. So So this turbine also you are able to apply the brake, and you are able to see here is the brake caliper, and you can see a brake dish, like a brake dish you can have in your bike. You can see the brake dish is there, and then there is a brake caliper also you are able to see. I hope you are understanding. So even there is a feature where you can apply the brake if you require for some purposes. Then to couple a gear mechanism, what we are talking into the first slide, to couple the gear mechanism, we require the coupling. So there is this kind of the coupling. It's called as the mechanical coupling, HS spacer or dumper kind of the coupling. And if it is a mechanical machine, the old era machine, the machine which is been designed before 1990 or 1985, they are having this right side. You can see there is a fluid coupling. So the coupling of the gearbox and the generator is done by the oil which is filled into this fluid coupling. And so this is also one technology, fluid coupling technology, and this is a spacer and the damper technology, which is a recent technology. Then next to this, we can go. We have to monitor. The technology is basically from, it's called as the pitch technology. So whenever the wind is coming, if the wind speed is more than 25 meters per second, the blade should allow the wind to go so that the rotor will not rotate. If the wind is less than 6 meters per second, then the blade has to stop the wind. So the blade need to move in this technology. So to move that blade, we require the motor. So here the main role of the electrical engineer and electronics engineer will come, where the blades has to constantly, we call the technology, is called the pitching of the blade. So the blades are basically responsible to turn the blade, turn the 12,000 kg blade, and that turning of the blade has to be done within 9 to 12 seconds. So it's a very fast operating speed of the blade. So you can understand a 12,000 ton 12 ton blade, one blade has to be turned by the motor, and that motor has to be controlled by the drives. Then there is a scope of the drive or the power electronics engineers will come. To operate those drives, there is a control system will be coming. There is a PLC will be coming. So on the left hand side, you can see a drive which is used for driving the blades so that they can pitch in or pitch out and maintain and regulate the output power. On the left hand, on the right hand side of, you can see there are three more machines. They are called the yaw drives. So there is a yaw motor, there is a yaw gear mechanism, and this will completely rotate the machine, because our is a yaw technology. When we talk about the our or all the multi-megawatt series turbine manufacturing having yaw technology, the purpose of yaw technology is that from whichever the direction out of 360 degree, from east to west, north, south, any direction the wind will be coming, the machine should face the direction of the wind so that it can generate the optimum power. So the complete machine, when we talk about 100-ton machine, is moving, is rotated by maybe 2 drive, maybe 4 drive, maybe 6 drives. So there are 6 drive which has been operated by the control system, and then the complete machine will rotate in the, suppose in the morning the wind is from east, in the evening the wind is from west. So in the day, in 12 hours, the machine has been rotated for 180 degree, and this is how the machine continuously rotate 360 degree. And for that purpose, the drives are being used over there into this technology. Now we can understand communication and control part, where, so now you can see, you can understand. Let me go back to the first slide where I will tell you, and then I can relate something. Here is the bottom. I hope all of you are able to see a tower. Are you able to see a tower on the slide? Yes, Shubhanshu ma'am?
Yes, sir. Yes, sir. We are able to see.
Are you able to see the tower? This is the tower? Yeah, fine.
Yes,
So at the bottom, there is something, called as the control, bottom control. On the top, here in the nacelle, there is a control, there is something. And into the rotating part, there is something control, we can see. So this all has to coordinate, and ultimately it has to be coordinate with the main office, which is into the wind farm. If there are more than 10, 20, 50, 100 turbines in wind farm, in a particular location, then it is called as the wind farm. So to coordinate, so there is a whole lot of communication takes place through maybe canvas, fiber optic cables, and all that. So I'm just showing. Sorry. Hello.
Continue, sir. Continue, sir.
Okay, fine. Thank you. So the communication has to be takes place within the machine and with the office and with the main office, maybe into Rostock or Germany somewhere. So it has to be done that way. So let me take you to the communication part. So you can see in the communication part at the bottom, generally there are PLCs are being preferred from the day one. So in the PLC, the programming is done. To the PLC, there are input output modules, the analog input output module, digital input output module. There is a control panel. There is a power section. There is a control section. There is, sorry. It's
So you can continue. There are some noise.
Okay, no issue, no issue. Thank you, absolutely. So you can see on the bottom, you can see there is a PLC and there are different modules. One module is a power supply, one is a CPU, central processing unit, then there is analog input output module, then there is a CAN bus module, there is a fiber optic cable module, then you can see a CAN bus module, then you can see a digital input output module. So you can see that it's a modular PLC. In a modular PLC, will talk to the top module PLC and they talk to each other. And when this is there into non-rotating part, that is called as the nacelle, and in the nacelle has to coordinate with to the rotor, which I was telling you at the one which is rotating is called as the rotor, the one which is stationary on the top of the tower is called as the nacelle, and the bottom it is called as the bottom section. From here, ultimately the power goes to the grid and it comes to your house. That is how the communication takes place. So top to bottom, 140 meters, there is a fiber optic cable. From nacelle to the rotor, it is around 10 to 15 meter. There is a CAN bus communication. From here to there is a module called as the Woodward module, where the grid parameter has to be monitored, and then there is a CAN bus communication. And nowadays this technology you can even access it through laptop, and you can access it through the Android smartphone, and you can see the daily and every moment generation, how much is happening, is there any problem, and you can having lot of very friendly technology today and come to a monitor, right? So this is how the communication part takes place, and together is to do it's. That's why I used to call this as a mechatronics product. It's a mechanical and electronics and communication, along with the automobile, and the chemical engineers are required because the blades has been manufactured by the chemical engineer and aerodynamic engineer. So when we look at this, this is a whole communication takes place, and they decide, depend upon suppose 4 meters per second, amount of the electrical energy which is being generated is suppose 1.8 megawatt, then it will generate. Amount of the wind speed is 12 meters per second, then it may generate 3 megawatt of the power based on the design of the machine. So as the wind keeps on changing, the power also keeps on changing, and the power will be generated. Together, the control system is responsible to control all the operations into the machine in synchronism. Now, when we talk about the bottom section, so you can see on the right hand side, I have shown one panel on one left panel. So here nothing will be visible, but there are the panels. So this kind of the panels or the cupboards you can talk on the left hand side, on the right hand side. So there is a control panel, and then there is a power. So there is a control panel separately. One is a control panel. You can see this. Then there is a power section. You can see this. Then there is a capacitor section. You can see this. What I mean to say, then there is a PLC, then SC terminal, there is multifunctional relay, transformer, UPS. So there are many things: UPS, transformer, relays, the switches. Then you can see terminals, and then PLC into the control. So it's a huge, huge panel, and whole engineering, whatever we have learned into engineering and all the components you are able to see in this part. Then power section, here basically there is an air circuit breaker. This panel responsibility the responsibility of this panel is only to connect to the grid. Grid means the power line which comes to your house, or which so it has to connect to the grid and disconnect. That is the only function of this power panel. And the capacitor panel, you might have heard about. The capacitor is a storing device. So the storing device are basically, it's a leading power factor component, So the leading power factor component will compensate the reactive power, and it will improve the power factor, because preferred power factor is 0.92 onward. So that's why power improve. The function of this is basically to control all the function of the WTG. That is the whole function of the control panel. Now in the market, the new technology has been come. It's called as the DFIG panel. So doubly fed induction generator panel. These panels are also working in synchronism with this panel, but they are few modified technology which is available and which is from 2010 onward. Now the new turbines which are coming with DFIG panel, right? So here is a huge scope for all the engineers from for electronics, ENTC, computers, and design engineers in power section. Now if we can open the panels, you can able to see this panel. Not much thing you will be able to see from there, but you can see there are the drives you are able to see. There is a PLC, there is a circuit breakers you are able to see. There are heaters, hygrostat, thermostats, and huge many components. So this is what is in the rotating part. This is what is into the top nacelle. This is again into the nacelle. So there are different technology having different panels which are there, and together this panel will be coordinating and it is synchronizing with each other, and they operate and generate the power output. Now, after every decade, we can say the new technologies are coming over there, and the wind turbines are classified in different technologies. So you can see the first fixed speed type. You can see the block diagram here. You are, as a student, you are comfortable with the block diagram. So the fixed speed. When I can talk about this fixed speed turbine, if I can do squirrel cage induction generator kind of the technology is there. What is this technology? That wind will come from here. It will rotate the rotor. The rotor will rotate to the gearbox. The gearbox will rotate to the generator rotor, because we know that generator has a stator and the rotor. Those who are from electrical background, electrical engineering, those who have learned. So there is a stator and the rotor. And output of the stator is given to some kind of the starter. We can call star delta starter, we might have heard. Soft starter, we might have heard. And there are different type of the starters. Dual inline starter, we might have heard. So first the power is taken from the grid, which is fed to the generator. The generator will generate the MMF magnetomotive force. After that, it will start generating the power. So all the basically those which are all the asynchronous induction generator will basically take the power from the grid first, and then give the power to the grid. That's why most of the time people used to call, they first work as a motoring mode and then they go into the generator mode. So you might have heard about the motor generator characteristic in your engineering syllabus. Motor generator characteristic. So first it takes power from the grid, a minimal power. That power which is taken is called as the reactive power. And when it feeds the same power to the grid, it is called as the active power. And if the power factor is poor, then we are having a facility, all the manufacturers who are there having the facility where they can compensate and improve the power factor and give the better power to the grid. I hope you understand. This is the type A. In type B, what is being done, that is called a limited variable speed. In the you can see same, there is a grid, there is a transformer, there is a capacitor, there is a soft starter, there is same generator, there is a gearbox, and then there is a rotor. So same technology, earlier technology, and this type A and type B technology is similar technology, you can see. But only here you will be able to see that the rotor, 3 lines, vertical line has been shown connection to the rotor. And then there is an arrow which is being shown as called as the variable resistance. So what I mean to say that with this rotor, you can add or remove the resistance. The moment you can add or remove the resistance, you are able to generate a slip. So generating the slip means you are able to change the speed RPM of the rotor. RPM of the rotor is a mechanical thing, controlling it by electrical and electronics. That is the beauty of the turbine. And these turbines are better in generation than the type A type of the turbine. That is what I mean to say. So this is the second class B turbine. Then people come, and as the evolution of the technologies are keep on happening, evolution of the technologies keep on happening. So earlier in first type A and type B, what I was showing was basically taking a power from the stator and giving to the grid. Instead of having only power from the stator, if we can able to take a power from rotor, because in the stator power is generated, rotor also the power will be generated. When I'm talking rotor, because it's some rotary transformer, yes, the power will also be generated into the rotor. So when we talk, can we take out that power also and feed that power also into the grid? Is it possible? So people start thinking, engineers start thinking, design engineers start thinking, can we able to do that? They have started doing that. And then they realize this, yes, we are capable of extracting the power from the rotor, and from the rotor then power can be fed from the stator to the grid, and power can be fed from rotor to the grid. That is also possible, and it is some kind of the partial defect converters which has been used over there. Then we can go to the next type of the technology, that is called as the full converter, D type. Here the only difference here in this technology is different than first three technologies, that the generator which is designed here is a permanent magnet type generator, permanent magnet type squirrel cage generator. So earlier generators as electromagnet generator, we don't require any kind of the permanent magnet, but there are technologies which are available where even in thermal power plant we are having permanent magnet generators, synchronous generator. So if you are having the magnetic generator, then you can, at any speed of the rotor, the generator will generate the power, that is the crude power, which is converted. So here is our power converters will come, that is cyclo converter, inverter, booster, amplifier. So all kind of the power electronics will be coming here, and they will be giving the desired 50 hertz, maybe 1000 or 690 volt or 600 volt output voltage with 50 hertz frequency. So whatever may be the speed of the wind, which will ultimately converted crude power, generate crude power. Crude power will be converted to the desired power of desired voltage and desired frequency, and then it is fed to the grid. So in this technology called as the full converter or permanent magnet squirrel cage generator, there may be a gearbox or may not be the gearbox. So in the market, the companies are available who are having gearbox and who are having non-gearbox technology also. So you can see that. So that is the technology fourth. And last but not least, what I mean to say, that there is a DFIG technology which is available into the market. You can see this is the block diagram which I am able to show you. So you can see a this is a generator and this is my rotor. So rotor will be rotating to the gearbox. The gearbox will generate to a generator. This generator is an asynchronous induction generator, and it will only generate the power when it moves beyond the synchronous speed. And when it, so this is the technology doubly fed induction generator, where the power is generated from the stator and fed to the grid. The power is generated from the rotor and fed to the grid. Power is coming from this side. Power is coming from this side, ultimately doubling the power. That's why it's called as the doubly fed induction generator. The doubly fed induction generator having heart and soul are these two panels. One is called as grid side converter, and second is called as the line side. It's called as the machine side converter, and second is called as the line side or the grid side converter. So when I'm talking about line side or grid side converter, it means this is a massive, these are the massive panels which are bigger than the control panel and which are the heart and soul. By using this kind of the electronic panel, you are able to operate a synchronous induction generator as a synchronous generator also. What I mean to say, you can operate it below synchronous speed, and now you can even operate it above synchronous speed. That is called as the subsynchronous, super synchronous, and synchronous. So all these three speed you can operate this turbine, and you can generate the power. So you can increase the power. Generation of the power will be as good as increase by maybe 37%, so that the earlier machine which was generating 100% of the power, now the same machine is generating 34%, 36%, 37% more power than the earlier technology. So now when you can talk about 2010 onward, the new machines whosoever is manufacturing is having the doubly fed induction generator. There are many companies who are manufacturing the DFIG panel. So there is a name like Woodward is from Germany, and then you can then there are some Chinese company, and then even from India there are recently new DFIG panels has been started manufacturing, and these DFIG panel will ensure the optimum power generation from the optimum wind speed, and that's why this is the most recent technology which has been used by. And when we talk about the most recent technology, I mean to say even nowadays the government stringent laws are not allowing the turbines to disturb to the grid. So they are also expecting that the better technology is there which will not disturb the grid, and it will be working as a standalone power station. So it is even somewhere it is mandatory that this technology need to be used, and without that you are not getting the permissions to pour the power into the grid. That kind of the things are expected from the wind turbine manufacturing company. So this is the most recent and most predominant technology from last couple of years operating in Asia and Europe basically. I think we'll conclude this session. I thank you very much for listening for last 15 minutes to me. I will love to answer your question if you are having any. Thank you very much to everybody, to Dr. Pandrinath Ghonge sir, to Shubhashri madam, all the technical staff and the student. Thank you very much. I would like to ask if any questions and would like to answer those. Thank you very much. I have done from my end.
Participants, if you have any questions, you can post it in the chat box. So there is one question. How the generator is synchronized with the grid as wind flow is not constant?
How the generator has been synchronized with the grid
as wind flow is not constant?
Yeah, that is what I'm telling, that when we talk generator is synchronized with the grid by when wind flow is not constant, but it is regulated because the blades are pitched in and pitch out, and it is the responsibility of the control system. Even the wind speed is fluctuating, the rotor RPM should remain constant. So that is the programmed given to the controller to control the blade angle such that the rotor will be rotating at the constant RPM.
Another one. If the direction of flow of wind changes, then how the direction of what is the direction of the generator?
Actually, the generator direction will never change because it's called as the from the rotor to the gear, rotor to the generator rotor. Rotor means which is rotating by the blade to the rotor of the generator. Everything is coupled with each other and they are in the same drivetrain. We call it a mechanical drivetrain. So its generator direction is not changing. The complete machine is moving in the direction of the wind, and it will ensure that it will always, and to do that, there is a program written in the PLC which will ensure and which will count the wind speed after it will keep on averaging the wind at morning 10 o'clock, how much is the wind and from which direction is coming. And there are two sensors which are associated with that operation called as the wind van and anemometer. It is their responsibility to ensure that the machine is yawing in the direction of the wind, and they will guide the controller from which direction wind is coming. Wind van will guide. How much wind is coming, anemometer will guide. According to that, the complete machine will turn.
Then one more.
Yeah, please.
Which type of
Good
optical
morning,
fibers are
Raj.
used?
Sorry.
Which type of optical fibers are used?
Which type? What he means? It's a coaxial optical fiber which we generally use into the communication, which we use for Ethernet laptop communication. Similar kind of the optical fibers we are using. Only the length is too much. It's 120 meter long, and it's basically designed to coordinate with the parameter. It has been decided how much parameters need to be coordinated and what is the speed. Based on that, it has been decided.
Sir, next
Good
one.
morning, Raj.
Yeah.
How the
Can you-
fluid coupling works?
How it is very difficult, to tell in 1 minute. It's very difficult to tell because operation of the fluid coupling, I can say in 1 minute that if you can take a buttermilk and you can rotate, if you can take a curd and if you can rotate the buttermilk, ultimately the buttermilk will be rotating and the suspended part into the buttermilk, how it rotates, in the same fashion the rotor will rotate. It's difficult to say directly. It is basically the fluid coupling is full of oil, maybe 93-98 liter of the oil. The gearbox will rotate the complete housing of the fluid coupling, and the internal oil in the fluid coupling will rotate the rotor of the generator, because in generator we want smooth increase in the RPM or smooth decrease in the RPM. So fluid coupling, purpose of fluid, it's called as the hydrodynamic fluid coupling. Hydro means oil, dynamic which is moving, and which is coupling, hydrodynamic fluid coupling. A fluid is rotating the rotor. Instead of directly, the rotor is rotated by the gearbox. That's why it's called as the hydrodynamic fluid coupling. It required a classroom session. I think on the webinar it is difficult to, because first it needs to understand the internal structure.
Okay.
But a very good question. It's a good question. It's an old technology. It's a good question.
Sir, is multiplexing used in optical fibers for this wind power?
No.
No. Okay. And one more. Can you brief about the site selection for wind power generation?
Brief, yeah. When we talk about the site selection, basically, the first and foremost criteria is the wind speed should be there. The first and foremost criteria is the wind speed should be there. The wind speed should be more than 3 to 4 meters per second. That is what has been expected, is the first important criteria. There should not be the gusty wind. That is the second criteria. That's why you can see the turbines not across India. The turbines are only right from Kanyakumari. You can see to Jaisalmer, to Rajasthan, to Gujarat. Only these states are there. You can't see any turbine into Uttar Pradesh or Haryana or that side. So you can. So first and foremost is wind speed. The second most important is wind speed is good, but at your Juhu beach, if we get a wind speed, it is the best wind speed. But we can't install because the land cost is more than the cost of the turbine. So we can't come and erect it into Mumbai. That is the second most important criteria. And then there is what is the pattern of the wind, what kind of the clearance we'll get, what is the cost of the land, whether the grids are available. Like you can go to Himalaya, but in Himalaya, you don't have the grid availability. So there should be the government grid, because without grid, two things are basically required. One is wind speed and second is the grid. Without that, your turbine is not able to generate the electrical power. So, and then there should be the roads, and then there should be the clearance, government clearance, and the land should not be the land of any mafia and all that. So you can't erect in those places. There are many parameters. Out of this, these are the few major important parameters.
Rajesh sir, good morning.
Very good morning.
I'm Dr. Gurmeet. My question is, can you please explain any core thrust research area in this your technology wind turbine, where researchers can resolve the problem? Which is the existing problem which researcher can start with?
Sir, it is all who want to do research, and whether he is a chemical engineer, then he can go into the research. If he is a chemical engineer and he want to do that research, then he can go into aerodynamic, blade, because blade is a good field. where you can do a lot of research. It is basically more focus in this technology is to how to reduce the weight and how to increase the power. How to increase the power. You can optimizing the power, reducing the weight of the machine. Even bits constant, you can't on the bits constant also you can work on the design part of the turbine, which is 59%, not more than that. So so if we can see in this technology, the first and foremost thing everybody is working right now in India, if he is an electrical or power electronics, he is working on the DP control panel system, designing of DP control panel, because that is the costly affair. If he is from mechanical engineering, then he is reducing that, how I can reduce the number of the thrusters and knocking down, and so that part they are doing. People from chemical engineering, they are working on the how to go from this glass fiber to carbon fiber, and how can we reduce the weight of the blade.
Excellent. Means there is a lot of scope in all the domains and fields.
All fields, there is huge scope over there, because any field you can take, because in India, NG team has just started developing a DFIC panel from before 3 years. In India, we don't have any manufacturer of the DFIC panel. Only most of the components which we are using in the wind turbine, any company are using from German based, or blades are designed in Netherlands. So here is a huge scope for each and every design aspect of the turbine.
We can work for Make in India.
Definitely, absolutely. Hey, this company Suzlon is we are indigenous. We are manufacturing everything in India. We are having working at 17. We are having a 17 location plants there across India, and we are indigenized. But still, there are a lot of scope for improvement.
Thank you, sir. Thank you for sharing your valuable ideas.
This is a very small session. 1 hour is very less for this technology. If I can get an opportunity, we can talk a long and long and long, because this is a huge, massive field. Thank you very much, everybody. I think it's time to close. Thank you very much.
Thank you so much, sir. It was indeed a great session. Thank you so much for taking out your time from your busy schedule and sparing 1 hour for the session. I hope everybody enjoyed it. So as we have come to the end of the 5 days webinar series, I now request our respected HOD sir to speak a few words to all the participants.
Respected dignitaries, I warm welcome to one and all for the voluntary function of 5 days webinar. Really, the journey of last 5 days are very cheerious to all of us. During this period, our eminent speakers make us aware about the challenges and opportunities in exploring field of electronics. Due to this COVID-19 pandemic, it's my privilege to acknowledge all our eminent speakers who has added the feather to this our platform by sharing their valuable knowledge with us. And due to their valuable times and sharing this platform and making us knowledgeable, so this platform, due to them, this platform becomes successful, I will say. It's my great pleasure to acknowledge our source of inspiration, our honorable chairman of Aldel Education Trust, Mr. Albert D'Souza sir, and trustee member Aldis D'Souza sir. Dear friends, we know every team has a potential, but someone required to give the proper directions. Our principal, Dr. Mulgun sir, has is the driving force to make this event successful. It's my great privilege, all the audience, for your active response, because your active response was the motivational force to all the organizer to organize the things and make the things available to make it successful. All the speakers were from the industries, from different industries. Some are from the IMDs, and of course, the cyclone of 2 days back before our programs and the relaxation in the lockdown. This thing make the changes in the plan of our speakers, and of course, it spread the shadow over our platform. But the patience and dedication of all the team of electricity department make this program successful. So I highly appreciate their dedication and their patience. Our student coordinator is equally supported to make this program successful. Really, the student coordinator, especially the Yash, Ankita, Jitni, and Dhruv, and Ashutosh also. The faculty has specially taken efforts. The Ronald sir, Bibin sir, Subhashini madam, Tushar sir, Sundar sir, Winner sir, and Sachin sir. So friends, really your efforts and especially the planning to make this program successful is very appreciable. On behalf of management, my principals, I again acknowledge all the speakers, audience, and my teammates. So special thanks for Rajesh sir, because of his very scheduled time and very small span of time, he could make his availability to make this program successful. Very thanks, Rajesh sir. Over to the organizer.
Thank you so much, HOD sir. Okay, now we have feedback from some of our participants. I now request Professor Waqar Ansari to share your feedback.
Good morning to all. Myself, Waqar Ansari. I'm assistant professor in St. Francis Institute of Technology and also pursuing my PhD in electronics telecommunication. During this lockdown period, actually, I want to connect my work with the recent trend, especially in electronics and telecommunication. I really want to thanks to the electronics telecommunication department of St. John College of Engineering and Management to make this webinar such a useful for me so that I can connect all these applications to my work. Especially the session was very good, effective, eminent personalities, the resource person also very good. I really want to say Dr. Kushal Tukle has explained the terahertz technology, and yesterday's also Mr. Ketan Patel has explained automotive communication and its security based things, because it helps me to explain encryption related content which I used to teach in my lectures. And even today's session also by Rajesh Sharma sir, wind turbine technology, like all these session was very useful, especially for electronics and telecommunication field. And I was about to search all these webinars in these days, and I find mostly IT computer related things. So I want to thank especially EXCC department of St. John College, who has done very nicely, well organized. 5 days session was really like smooth with full dedication. So I'm very happy to join this session. Thank you, sir, for giving me opportunity to share my thoughts over here. Ronald sir, you have given me a message yesterday. I was happy, like at least I can talk about the feedback of the session. So it's great one.
Thank
Really
you so
great.
much, sir. Thank you so much, sir. We appreciate it. Now I request Dr. Gurmeet Singh to share his thoughts.
Dear participants, organizers, and the management of St. John College of Engineering and Management, I'm Dr. Gurmeet Singh from Guru Tegh Bahadur Institute of Technology, New Delhi. It gives me immense pleasure to share the feedback of such a nice 5 days webinar. on exploring the emerging dimensions of electronics by the Department of Electronics and Telecommunication Engineering. The FDP was very nice and informatively organized. They have covered all the exploring and emerging technologies and various aspects of electronics like IoT, mobile network evolution, terahertz technology, and various automotive communications and its security. And the best part is today's wind turbine by Rajesh Sharma sir. He has explained all the various panels and also shows the images in a nice way. It was like a practical exposure to all the participants, and it was like a ocean in a port with sincere efforts. जैसे हिंदी में कहते हैं ना गागर में सागर. He has crisply explained all the parameters. On behalf of all the participants, I am very thankful to all the faculty coordinators, Professor Subhanshi Shukla, Professor Bipin Matthew, Professor Ronald, and all the coordinators for organizing, coordinating and managing such an excellent event, and good speakers. Student coordinators Yasha and Jenny Patel have also put their best efforts and patience to address and resolve all the queries and coordinating this event in a nice way in this tough time of COVID and cyclone. I think we all should give big hands to all the pillars behind the success of this event, like the management, head of the department, Dr. Pandhari Nathji, and sir. At last, I wish all of you a safe and happy life and hope for such more nice FDPs in the future from all the organizers. Stay home, stay safe. Jai Hind, Jai Bharat to all of you. Thank you very much.
Thank you so much, sir. Now I request Professor Sashi Prabha to share her thoughts.
और किसी कौन स्पीच देगा बाबू चांस पे जा रहा है पानी पी रहा है
I think ma'am has some issues, so we'll continue. I, on behalf of staff and students of SJCM and the entire fraternity present here today, and on my own behalf, a very hearty vote of thanks to all the speakers for taking time from your respective schedule to grace this occasion. We all are inspired as well as enlightened by your great session. I would like to take this opportunity to place on record a hearty thanks to Mr. Aldrich D'Souza, member of Aldrich Education Trust, our principal, Dr. G.V. Mulgund, and our HOD, Dr. Pandrinath Gonge, for their support and guidance they extended for the smooth conduction of this 5-day webinar series. I also want to thank my team, that is Ms. Subhashni Shukla and Bibin Matthew, for helping me in each possible way to make this webinar a success. Finally, I also want to thank our department professors, Mr. Sundar Kharvi, Mr. Vener George, Mr. Sachin Kole, and Tushar sir for the assistance they offered. And most importantly, I want to thank our student team, Yash Shah, Jayesh Patil, Altaf Sheikh, Ankita Biswas, Jeannie Patel, and Dhruv Shah. Without their help, this webinar would have been very difficult because everything they managed, especially Yash and Jeannie, were continuously on Telegram and solving the queries. So I want to thank each and every student here for guiding us and supporting us and helping us in through this webinar series. And finally, I want to thank all the participants who joined in this webinar series. Thank you so much. A few instructions to the participants. Feedback form will be posted in the Telegram group and it will be activated till today evening 6 o'clock. So participants, please do not forget to fill the feedback form. E-certificates will be emailed to the participants who have filled the feedback forms within 3-4 days of on their registered email IDs. PPTs and other materials shall be shared after taking the proper consent from the speakers. Thank you everyone. Have a very great day. Stay home and stay safe. Thank you so much.
Madam, group photo.
Participants, you can start exiting the group.
So photograph.
Yeah, sorry, I request all the participants to switch on their cameras. We'll have a photo session right now.
Request Rajesh sir also to switch on his camera.
Rajesh sir, please switch on your camera.
Right, sir.
Just stay back for 2 minutes and we'll just complete quickly with the photo session. Okay, we are done.
Thank you so much, participants. Have a great day ahead.
The feedback link is posted in the Zoom chat box, so kindly fill it without fail.
And if any queries or any certificate not received within 3-4 days, you are free to message us. We will solve your query. Thank you so much.
Donald sir,
Yes, sir.
can you please share the PPTs or other relevant informations?
Yes, sir. Whatever PPTs will be there, we'll take the consent of all the speakers and together we'll post it on Telegram group, sir.
Okay, sir. Thank you. Thank you very much.
To everyone.
Thank you.
Thank you so much all the participants for supporting us in our whole webinar series. Thank you so much for your great response. You have been an amazing audience. Thank you so much everyone. We shall here conclude the meeting.